you.
Thank you. Well, it's 3:30 p.m. here in Sharm el-Sheikh at COP27, so I'm going to start our segment in the Buildings Pavilion on the future of building, supportive passive house training at higher education institutions. So this series of presentations that you're going to hear this afternoon is led by the International Passive House Association with the following partners: the Passive House Institute, the Passive House Association of Ireland, and FIDIC, the International Federation of Consulting Engineers. And the focus of our talks this afternoon is a lack of capacity within the built environment sector with respect to knowledge of passive house. And so this is an urgent call to the higher education institutes around the world, and indeed I think some of the major consultancies and other institutions, to increase the availability and capacity to instruct in passive house approaches and techniques. So we have an impressive array of speakers to discuss this with us this afternoon. I'll ask them to begin their presentations in accordance with the following order. So we're going to have initially Professor Dr. Wolfgang Feist, the founder of the International Passive House Institute. He will be followed by Suzanne Winkel, Head of Professional Training and Certification at the International Passive House Institute. And we will then hear from Barry McGarren, Chair of the Passive House Association of Ireland. If we're lucky, we may have a fourth speaker, John Bootland, who's the Chief Executive of Passive House Trust, but we've had some trouble locating John this afternoon. As for myself, I am Robert Spencer. I'll be moderating these discussions this afternoon, and I am the Global Practice Lead for ESG Advisory at AECOM. AECOM's an international construction, design, engineering and environmental services consultancy. And just from a personal note, I can say that as we're moving into this era of decarbonisation around the built environment, then there certainly is a massive need for a training and development effort across the sector. And we haven't been falling short of that here at AECOM either. So by way of example, a couple of years ago, I led a task force within the AECOM Buildings and Places business in the United Kingdom to develop a net zero emissions buildings training program for all 3,000 staff across the UK and Ireland business. And that training was completed by almost everyone within that cohort. So nearly 3,000 practitioners trained up across a 9-module training program, which included a significant element on passive house techniques and approaches, incidentally. And this year we're going to be taking that training further with an optional 40-hour deep dive on understanding carbon within the built environment for our practitioners globally, which will be undertaken between now and Christmas. And that is a part of an effort to increase the level of understanding and literacy across net zero emissions buildings and low carbon buildings, in order that we're offering the best possible solutions to our clients in this field. So I'm very excited to hear about how this can be taken further, and indeed how we catch people earlier in the education process at the higher education institute, so that by the time those people are entering the work environment and become employees, they already have a significant amount of training and capability under their belts, which they can deploy effectively within the built environment sector. So, on that note, it's my great pleasure to invite our opening presentation from Dr. Professor Wolfgang Feist, who is the founder of the International Passive House Institute. And I've asked the professor to focus on the principles and benefits of the passive house building standard. And Dr. Wolfgang, if you could speak for 10 minutes or so, that would be wonderful. Over to you. The floor is yours.
So, Thank you. Thank you for that introduction, and good afternoon, everybody, and good afternoon in Sharm el-Sheikh. So my role will be to introduce you to the passive house. Now, what is it? First of all, it's just normal buildings. And if you look at this photography, well, it's very difficult to see anything which is different from what we normally build nowadays. And that's the truth. So in order to see what are the essential parts of such an energy efficient building, we have to have a look on the cross-section. And in the cross-section you'll see, yeah, well, there is much better insulation in the building envelope. We avoid thermal bridging. We have improved windows, looking the same like the normal windows, but they are quite improved. We make an airtight envelope, and we have a ventilation system. We have seen how important that is, especially if we have a global pandemic, for example. So always enough air, but with a heat recovery, so that we can exchange stale air by fresh air without the energy losses you normally have. Now, that seems very simple, and it is that simple, and it might be a little bit surprising that with just these 5 principles, which should be just normal to use in a new building, you can achieve a very good performance of such a building. Compared with a conventional building, which in Germany has around about 128 kilowatt hours per square meter in year heating consumption. By the way, heating is making up about 1/4 of the world's final energy use and is the second biggest part which is contributing to climate change. The passive house only has a 50 kilowatt hours per square meter in year final energy use. So there is a massive reduction in the energy needed to have a good climate inside of that home. Now, if you see this, if you see, well, very high reduction, how is that possible? Or is it even true? Is that reliable? And there's a publication which has just the title of what this slide here says: are the energy savings of the passive house standard reliable? You see the QR code here, and you can have that publication and have a look at that. I'm just showing these are the measurements in that is more than 104 passive houses built in developments. All have been measured, nothing left out, and the average value measured for the energy consumption in these buildings have been 14 kilowatt hours per square meter in year. So this meets very well what we have seen in the last slide. So yes, it's reliable. We can really build buildings in a way that they consume only about 1/10 of what is normally used. Now, in the developed countries, most of the buildings are existing buildings. So if you want to change something on the energy use of buildings, we have to deal with the existing buildings. Can we apply these technologies? Can we apply these experiences to existing buildings? And the answer is yes, and it has been done. This is just one example. There are thousands of more examples, not just in Europe, also all around the world. Starting with an existing building, which might have very high energy consumption, 200 kilowatt hours per square meter a year, it's possible to reduce the overall amount of energy needed here by a factor in a range of 8 to 9. And this is a very important possibility, and it's interesting to see how this can be done and how it can be implemented in the existing building stock. This is an example showing also a thermographic view. There are lots of these examples all around the world, very impressive. Partially is one in New York, where you can see such an example. The key to all these improvements are, of course, the components of a building envelope. And I show you on the example of a window how that can work. So this is a company producing windows, and they come with a window they already produce or they want to improve so that they can meet these energy efficiency standards. So an expert can calculate what the energy performance of such a window will be, and we will look whether it will meet the criteria for the passive house efficiency. Sometimes it does, sometimes it doesn't. So there may be some loop, maybe 2 loops, maybe more loops, and then we can improve that window, and it's an improvement by factors 2 or 8 or even more. So at the end, there will be a window which is much better than the original one. And that is on the market, so it's available for everybody, and it can also be used in ordinary buildings. If you want to see further information on that topic, there's one publication is just published about the experience using single-room air conditioning units for a full house heating in passive houses, also cooling. Very interesting results here. We have a new campaign at the moment, Efficiency Now, where we show how we can apply these kinds of measures also to existing buildings and how everybody can do it, maybe also by himself. And the major link to that is the Passipedia, passipedia.org. So if you want to get more information on that, you can just also use these QR codes given here. So passive houses, it started from an idea and from scientific research using, well, it's science known for a long time, building physics, theory of heat, all these things which are well known and which are not changed. They are just that physics which is used here. And now becoming a widespread, internationally successful solution with a lot of examples. All these examples you see in this slide are built passive houses. One remark, everybody can build such a passive house. It's not patented, it's not proprietary, it's open, everything has been published, what you need for that. It's a possibility to use the know-how gathered by the scientists working in that field in your specific application. So thank you very much, and I'm giving back to Jean-Michel.
Thank you very much indeed. Listeners, that was Professor Dr. Wolfgang Feist, founder of the International Passive House Institute. Thank you for such a clear and accessible presentation of the passive house approach and how it's readily achievable provided the right ingredients are applied. So I would now like to move on to our second speaker. And here I'm going to invite Suzanne Winkel, who is Head of Professional Training and Certification at the International Passive House Institute, to speak to us. And Suzanne will speak for about 8 minutes, and she's going to cover passive house in higher education, how to teach sustainable buildings. Suzanne, the floor is yours.
Thank you very much, Robert. I hope you can hear me here.
Yes, very well.
Thank you. Okay. So, yeah, it's a great pleasure for me to speak to you here at the COP, even if not in person, but then online, and I hope that this can give you all the information also in this way. Yeah. After this overview of the passive house standard from Wolfgang Feist and also the need for high energy efficient design in new construction and also retrofits, my part now would be to give you an overview about the training concepts we developed at the Passive House Institute that will enable building professionals to respond to this need and to integrate high energy efficiency into their daily professional life. So maybe you are asking, we are training architects at universities and so on, but why do we need a special training for high energy efficiency? So maybe we have to ask first what knowledge really is needed to be fully prepared for the current and for the future challenges in the construction sector. And maybe we have to ask also is maybe something is missing in our current educations. So I want to give you a few examples now what can be expected in the passive force training offers in our course system and why this is needed. But you don't have to be afraid. I won't go much into the details of the slides. So there are some excerpts from the passive force training. I just want to take them to give you an overview what you can expect there. Okay, so let's start from the small and then going to large. High energy efficiency is not only, of course, but it is also about details. And it's about the impact of those details on energy efficiency, which is often much more than we usually expect from my experience. And building professionals really have to know about the impact of their planning on energy efficiency and what are the consequences if details are not thought through to the end. Yeah, but of course it's not all about details. It's all, of course, the whole passive house concept Wolfgang gave you an overview before. And it's also building high energy efficiency is also about understanding the scientific background, especially at renovations. That's very important because maybe you know that you have to find at renovations specially adapted solution for each project, and sometimes several details are different in one project. So we should really make sure that building science is the basis for decisions of building professionals, and especially for those who are starting their career and therefore don't yet have sufficient experience, of course. And in my experience, also being an architect, remembering starting my career several years ago, there is a lack, or there was a lack also in the education at the university. You know, we know it's all about money also. And in my experience, this is also often missing in technical education systems. But building professionals need to understand that investment costs, of course, have to be considered together with operating costs, and they have to know how to calculate them. And so the passive force training will help them to make their planning and their consultations not only technical, sound and safe, but also economical. And then we should talk about renewables. This is a very important topic, of course, for all of us. It's absolutely clear and no question at all that we need to deal with, renewable energies to deal with the climate crisis. No question about this. But sometimes we have to have a closer look here. For example, the use of solar energy, especially in cool climates, it's not enough just to take fossils out and take renewables in. Even if we would have enough renewable energy all over the world and matching our consumptions. In many countries in the world, for example, solar energy, it's not enough solar energy in wintertime there to supply our buildings with poor insulation standards. You can see here the gray bars. It's a conventional building, what you have to build now in Germany. And you can see the orange bars here, the consumption over the month from a passive house. And the yellow dots are the gain of solar energy in Germany, for this example. And you see that it's really needed to get this consumption down. And our future architects, designers, and decision makers have to know about this and take this into account. Then talking about renewable energy, we have to also ask, do we calculate and do we balance them correctly? So this was a question for the Passive Force Institute several years ago. And the Passive Force Institute developed a system which takes into account which renewables can be used directly for which consumptions in the buildings, and what has to be stored, maybe from summer to winter, and therefore immense losses have to be calculated and taken into account. So the last examples, there was, as I said, an excerpt of the Passive House training.
And this, sorry to interrupt you. We're understanding that the live stream is not getting the presentation, and can I just check if you're sharing your screen?
It says that it shares the screen.
It's saying that it is sharing your screen. Okay.
So should I stop and go in again? This could be a possibility.
Yes, we could try that.
No. I get the stream, so the stream is working
The screen
on
is
Zoom.
working.
So maybe there needs to be a connection between the Zoom and the presentation broadcasting.
The broadcast, yeah. So I think the broadcast is not picking up the
It's
Zoom
passing now.
screen sharing. Okay, they're sorting it out now. Don't worry. Sorry to interrupt you, Suzanne. Please
No problem,
continue.
no problem. Should work for all. But I can see my last slide here on this screen.
That is the Zoom stream.
There's the Zoom. Okay.
Yeah. But that's
Okay,
okay.
just give me.
It's okay, and I think almost everything was easy to understand, even without the slides. So I think we should go on.
Okay.
Because that's better than to have a abrupt.
Yeah, I've just seen the live streaming, and it seems to be working now. So that's great. Please
Okay.
continue.
Thank you. Fine.
Okay, so I can go forward?
Please do, yes. Please proceed.
Okay, thank you. So so I showed you several examples here. What is necessary to know for building professionals, and this is especially needed to know for our future building professionals, so for our students. And this kind of knowledge is really crucial for them. It's very important that we not teach them how we built our buildings in the past. Yeah, they have great challenges to meet, and we should help them to be prepared for the future, how they should build and plan our buildings. So, of course, maybe you're asking how to get those trainings. Where is it offered and by whom? The Passivhaus Institute developed a training pathway. So we have trainings for different target groups, for people on site, tradespeople, craftspeople. So this is this yellow, this orange part here, and trainings for designer, architects, engineers. This is the red one here. And then we developed also some in-depth training because we saw that for different target groups, it's needed to have some special trainings which goes much more deeper into details. And of course, we cannot teach here from the Passivhaus Institute all people around the world. Therefore, we have many course providers around the world. You can see here a map of them. And you can find all those course providers partnering with Passivhaus Institute on our website, passivhaus.com/training. And those course providers really make a great mixture of different training methods, so online, in class, live online, live in class, online on demand, what you like. And what is equal for all is that they have at the end an exam, and passing this exam, people can get the certificate. So there is a quality proof of knowledge on energy efficiency all over the world. And this, of course, is also then a proof of qualification for their students and internationally recognized. We are working together with several cooperation partners which are training professionals, people who are already on job, but of course it's very needed to get this knowledge into the university, so to the young people or future building professionals. So we have several cooperations here with universities, can see them here. But we are doing our best, of course, to increase this number. And this is very crucial that we increase this numbers of university talking about Passivhaus and teaching Passivhaus. So if you have any contact, or maybe you're working at the university and on your own, please get in contact. You can find here the email address from the training department and also our website once more, passivhaus.com/training. I thank you very much for your attention, and I would love to answer your questions later. And if you want to get in contact, we can talk about how you can implement this high energy efficient knowledge for your students in your university. I would love to do this together with you. Thank you very much.
Thank you very much indeed, Suzanne. That was great. I think we're ready to move on to our third presenter, and I'd like to invite Barry to come off mute and be ready to speak. Barry, Barry McGarren is the chair of the Passive House Association of Ireland, and what Barry's going to do is talk to us about passive house buildings and their impact on university campuses, lessons that we can learn there. So what is it like to effectively walk the talk of passive house in a university campus? So over to you, Barry. Looking forward to your talk.
Thank you, Robert. And that's exactly what the talk is going to be around. I'm fortunate enough to work in effectively the largest passive house premium building in the world, and that's located in Northern Ireland at Southwest College's Earn campus. But before I maybe talk in a little bit more depth about our own college, we're one of a number of education institutes around the world who are building some of their estates buildings to the passive house standard, and they are also having really positive effects like ourselves in Southwest College. This building here on the screen is in Australia with the Monash University. Quite a striking building, I'm sure you agree. And this is very, very striking. This is Cornell Tech's one of their university buildings there just across from Manhattan there, in between there and Queens in New York City. And then this is a retrofit to the passive house standard at Humber College, which is in Toronto, Canada, as well. And then the last slide I have here is really our own building. And as I said, that is the world's largest passive house premium building. So what I really want to do from this point is talk about the impact that is having in our own college and to the construction sector, the training that's going out to the construction sector in Northern Ireland and Ireland. So for us in Southwest College, back in 2015, we were then part of the EU, and we had an EU-funded project, and that allowed us to, I suppose, dip our toe in the water and build a building to the passive house standard, and that was a £1 million building. And in lots of ways, that was the case study for us to build our bigger building, which was a £30 million building. But at that point, when we built that first building, we became involved with the Passive House Institute, and we started to deliver on some of the programs that Suzanne has just outlined in the last presentation, in particular for us, the Passive House Tradespersons course and the Passive House Designers course. And since that time, we've trained over 500 designers and tradespeople, give or take. And that's, the numbers there might be quite modest for some, but in the Northern Ireland context, that is quite significant, the impact that has on the industry. And then I think it's important to show the before and after in lots of cases. And for us, this picture here shown on screen was our existing college building before we built our new campus. And it was a typical education building of the UK and Ireland, built in 1971, a very bad energy rating. It was using over 100,000 litres of oil a year. And that at the time was costing the taxpayer £51,000. But we now know, this is a good illustration of what's happening with the energy crisis at the moment. If we still had that building today, that £51,000 cost would have at least doubled. So when we had the opportunity to build a new building, like the wee case study building that we had before, we wanted to go to the best standard we could, and we wanted to future-proof for as long as we could as well, whenever we did get the opportunity to build the building. So that's what we did, thankfully. And it's built to the passive house standard. So there's a lot of text on this slide, but really the key point on this one is that the building has gone from 100,000 litres of oil right the way down now. Then that was costing £51,000 at the time. And the expected running cost for the Earn campus in terms of just heating is around £6,000. So that's a £44,000 saving a year for the college. And if you extrapolate that out over a reasonable time frame, we're well across £1 million in saving, not even to mention the carbon emissions and everything else that will come from that. And in Wolfgang's presentation, he mentioned as well the significance of the pandemic. So not only are we getting lower energy costs and we're well protected and going forward, and our students are able to learn about this firsthand, but also we're able to demonstrate the performance with respect to indoor air quality. And here is a graph showing the outdoor temperature and the indoor temperature for our building. So our building is delivering as expected, and it's so far the average for the building has been 21 degrees, which it was designed for as well. And then on the indoor air quality, which I just mentioned, this is really striking as well. Again, without doing a deep dive into the science, this building's CO2 parts per million is just less than 500, which is almost the equivalent to the indoor or outdoor air quality. So it's true to say that our indoor air quality is almost as good as the outdoor air at our campus in Enniskillen, which is fantastic. And again, that relative to the pandemic is a very healthy air quality as well. And then for us, and more now to the students and how this is really starting to impact on our teaching and learning, which this talk is all around, is that we realized already 1 year post-construction opportunities for some of our students to attend Humber College in Toronto, which you've seen at the start, and also Penn State University as well. So the whole passive house thing, one of the very strong calling cards of passive house and why it's such a good standard away from the science is that it's a global standard. You can build, as you've seen at the start, a building in Australia, a building in New York, a building in Ireland, and again, Central Europe and elsewhere. But that also allows us to, get talking to a larger network globally as well. So for Southwest College, we were able to provide these opportunities for our students. And next year, this is getting expanded as well. So very exciting times with respect to that as well. And this is what we are teaching our students as well. It's really around, they're getting their traditional education, be it in architectural technology, building engineering. But what we're bringing in the fashion of guest lecturing is demonstrations and tutorials around how to use some of the passive house tools, such as Design PH, and talking through some of the advantages of using a program like that. And then we take them step by step through it, talking around, using this software as a design tool. So telling them about the implications that their choices will influence the building performance, but also the carbon that's produced from that building forevermore. And then we use the PHPP in conjunction with this as well to illustrate, I suppose, if we substitute figures in the PHPP for the traditional building control figures, we're able to illustrate to them just exactly how much influence that will have on running cost and different things. So it's a very good interactive lessons that we produce around this. And then we use other softwares that are third party, around thermal bridging and, also embodied carbon, and then the WOOFY software, which looks at moisture in buildings. So really it's the introduction to some quite advanced building science that we're able to deliver as well. And more we're seeing this come across into visualization tools as well, which is very good again for the younger generation to sort of see and to communicate through that medium as well. And the last slide that I have here of these third-party ones is really the embodied carbon. So again, with this being an event at COP27, the operational carbon has largely, I was going to say address, but that's not true. What we have is we have the tools to deal with operational carbon by and large, but now the real challenge is to deal with embodied carbon, and we're bringing that into play as well now. But the catalyst for all of this has been our new building. So I suppose in conclusion, for us, we feel that our college building has actually broken a glass ceiling in the Northern Ireland context, and we're now seeing with some other public buildings coming after the Earn campus that they are also looking to go the Passive House standard as well. So it's a really good development in the Northern Ireland context. And for us in the college, again, we're able to now explore and achieve, international links and collaborations with other universities that I've outlined. So that's really the bones of my presentation. The one last slide that I have here as well is around, since the building has opened, we've really used it as a catalyst for life in the college and in the university largely, where we have students, but also the staff, wholly embraced in a step change around sustainability as well. So it's been a bit of a living lab in lots of ways. So again, like Suzanne, I'm looking forward to taking questions whenever we're finished the presentation phase. So I'll hand back to you, Robert.
Thank you very much, Barry. That was excellent. Really good to see those examples from Northern Ireland and around the world on what you're achieving. Particularly impressed with the air quality that you're getting inside the building as well. That was interesting to draw out. People usually focus on the energy, but it's good to see that the well-being in the building is really on the increase as well with that air quality piece.
Thank you.
Great. Well, look, I think that concludes the formal presentations, unless John has managed to join us. I haven't noticed. Do we have John there? John is there. Great.
I am here.
Hello, John. You are very welcome. So let me introduce you. So everyone, we're very pleased that we have John Bootland here with us. John is the Chief Executive Officer of the Passive House Trust. And do you have any slides, John, or are you going to talk?
I do. No, I do. And apologies for being late to join you.
Please do share your slides, John. And while you're doing that, I'll just let people know that John's going to talk about Passive House on campus and looking at promoting and campaigning next door. So let's see what you've got to say on that, John. Thanks very much. Over to you.
Great. So I'm really pleased to follow Barry, actually. And I'm going to take a more theoretical approach or to look at how we approach education for Passive House in the UK. So not just about one building, but about how we approach it across the piece. And I just wanted to set out one of our targets that we set within the last few years. So in 2020, we set a new 5-year plan. And our middle target here is that we want 50% of all the industry, all the construction industry in the UK, to be trained to Passive House or equivalent standards by 2030. So that's a huge task. 2 million people involved in construction in the UK. So that means we want to try and get training out to 1 million of those people to get them some understanding of Passive House and ideally able to deliver something equivalent to that or at least on the journey towards that. So very ambitious. It's been really entertaining to try and work out how we might do that. And to try and deliver that training or to start to scale up our training, we're doing several things. So one of which is to do the mapping of all the gap analysis of where the extra training is needed, whether that's on site, for the specialist trades, for the architects or whoever. And also then to map that against the UK training regime, so qualification regime effectively, that people go through. So your professional development training or your college-based training as well. And we're also developing a learning hub, an online learning hub with lots of detail and access to online training as well. And I'll talk through these in a little bit more detail for several of them. I'm just going to pick on a few of the items that we do. So we work at all sorts of levels, from university training, but also design competitions, and then through partnerships. If you can imagine trying to scale out the training to hit 1 million people, we're not going to be able to do that ourselves. There are real constraints on being able to do that. And the only way that we can do that is through partnerships with existing regimes and systems. And there's a few of them listed on the right here, but there are more that we're working with. So it's going to have to be feeding our information into huge numbers of existing organizations, existing training partnerships. And just one that I wanted to pick up on to begin with. I better say that I'm standing in for Yogini Patel, who prepared most of these slides. So I'm the Chief Executive of the Trust, and she couldn't join us today, unfortunately, but would normally talk about this. It's more, she leads on much of this area. But we start work from the very beginning with the young trainees for the industry to try and take our way through all the way through to the current professionals who are delivering on projects as well. And there are several groups active in the UK. I'm sure this is the same all over Europe and probably around the world. A lot of the school children and the young university students are very driven to try and deliver change on sustainability and on climate particularly. So it's a very fertile audience for us to work with. So Teach the Future is a group in the UK who we actively try and help and support. And we also have some design competitions that we work on with several university groups. So for example, we worked on the Icebox Challenge with help from Georgia and the EFA team, among others, and using Edinburgh Napier University. So you can see the iceboxes here that were based in Glasgow at COP26 last year. I don't know if there's something similar happening this year. But these iceboxes, they were used for public display to show the effectiveness of passive house design and construction in retaining the ice during the Glasgow summer. And the iceboxes have now gone to a training centre in the West Midlands in England, and they're being used to help training with students as part of the student competition as well. And we're looking at potentially doing some flatback boxes that could be deconstructed and moved from site to site next year, again with the students that we were working with on the first competition. We also have a University Design Challenge. We've actually been running a design challenge with university students for about 6 or 7 years now. We have over 100 students nearly every year. Typically involves 4 or 5 different universities, and the little teams of students come together. They work on a real building design, and we give them training and teaching about Passive House, or our members do. They bring we bring external tutors in to help them to sit in on the design studio work that they do. And so far in the current competition, 57 universities have been involved, and over 150 students were involved in little teams to come together with the buildings. They all work on, as I said, on the same building site at the minute on this current project or on this current challenge. And then the winners are selected from the team that has designed the most effective passive house approach to those buildings. In this case, it's a timber building, so we're working with Timber Development UK. We have in the past worked on concrete buildings, worked with one of the big concrete companies in the UK as well, just to show that passive house can be done using any kind of building type and any kind of structure. I won't go into any more detail. There's lots of workshops and teaching and engagement. I think there were 17 different seminars that we provided for them as part of the 22 competition. And again, EFA and the Passive House Institute have supported us in this work, and they are co-sponsors with us on this competition as well. The other thing that we're doing particularly at the moment, which is fairly new for us, is that we're starting to do mapping against the qualifications. And for example, university level training in the UK, we have the standards called NVQs, which is National Vocational Qualifications, and they have levels 4, 5, and 6 are equivalent to years 1, 2, and 3 at university. They also have levels 3 and 7, so 7 is post-university, and level 3 is kind of at late school years levels. And we're trying to work out how we package up the training from the chartered Passive House courses into these standard qualification modules that can run out through colleges. There are hundreds and hundreds of colleges all around the UK. And if we can build our materials into those college packages, then that will be a very effective way of getting learning information out to a massive audience. So that's something we're working on actively at the moment. Maybe have the first materials next year, hopefully on one of those levels. It includes practical and also theoretical training as well. And these are the kind of numbers that we've delivered. Just remember back to that million number. So in 1 year, our numbers are about 400, 500 people through the certified Passive House training. We then do the more expert training on things like on retrofit or on how to deal with large and complex buildings. And I get about another 300, 400, 500 people. And over 1,000 people so far through the student competition in total, not just in 1 year, but so far. So we need to ramp these numbers up significantly. And one of the things that we have coming up at the moment is a partnership with the architecture schools in the UK. So every architecture school in the UK we're working with to develop a basic set of modules that we can feed Passive House into the beginning of their training for every architect. And that's 16,000 people a year. So that's helping us move towards our enormous target of 1 million. Still a long way to go, but it would be a big scaling up of what we're able to achieve. We do have lots of other training, not just linked to university and students. All of these are modules that we've produced as online training. So the move to Zoom meetings and Teams meetings has helped in terms of being able to video record lots of training that we've produced. So these are all available on our learning platform as downloadable, just standard information. And we're also very particularly keen to work with different client groups. So we do training for client groups as well. So social housing clients, private housing clients, school and education building clients, so universities and schools. And we've got various levels of introductory training and then more detailed training on how they can effectively get through the procurement process and make sure that they get an excellent performing Passive House out of that at the end as a client, not just as the designers and contractors. So different training for different audiences as well. And again, we have numbers for those. So during 2021, we had about 400 people for our conference, which is where we aim at bringing new people in to persuade them to pick up on Passive House. And then the clients for educational buildings, so schools and universities, nearly 800 client attendees at our training for that as well. And we're just starting to see the effects of that coming through as we get new schools and new universities being commissioned for those kind of buildings. And that's it. That's where we're working on the education side. So yeah, happy to take questions, and I hope that's been of interest.
Thanks very much indeed, John. Really interesting to see the scale of your ambition there, and also what you've managed to achieve so far with those training approaches. And my first question is actually possibly to you, and I think Suzanne might have a view on this as well, because we've talked a lot about the architecture training schools, but you know, a huge amount of the work actually will get done by tradespeople, particularly with the MEP. You know, areas of interest, the electrics and the plumbing, and other trades to do with you know, the window fittings and so on. So how are we addressing that cohort of folks and bringing up the capacity there? Suzanne, do you want to go first?
Yeah, thank you for this question. So as I showed in my presentation, I'm not sure if everyone could see the slide. So we developed several years ago. First, we started with an education program for designers, for architects and engineers and so on, architects and engineers. Then we developed a special training focused on people working on site, tradespeople, craftspeople, and yeah, and this is very important. And what we are training there is that we want to bring the different people on site together, that they learn about the other side of their, so all people on site have to know what the other people are doing. So this is very important to bring all those parts together. And as Barry and also John said, so they also, so at least Barry and Southwest College, I think also in the UK it is done, that they are training tradespeople with this training program. And this is especially important for the part of the retrofits, because we know, so in Germany it's the case, I think in many countries also, that for retrofits, sometimes for small buildings, really no architects are consulted. And then it's very important that our tradespeople, our craftspeople know about high energy efficiency on site and on retrofits, and we have to train them. And I'm very happy to see here also talking Barry and John talking about this education that is implemented in so many cooperation partners, and their things what they are doing. Thanks you from my side also from on this point here.
Thanks, Suzanne. John, did you want to add any extra layer on there?
Just very briefly, that we do also have the installer or contractor training as well. So, for example, the rigs that I talked about, or the ice boxes that have gone to the students in the South West Midlands, also in Scotland, there's an organisation called BEST, and they have some rigs that have been built, so we can demonstrate to people how you do the taping, for example, or how you fit windows in. It is absolutely crucial. And when we first started training in the UK, and people were bringing very high quality windows over, say from Germany or Austria to begin with, we would say to them, you have to bring a team with you, because in the UK, people just don't know how to install these windows, and you're not getting the value of the quality because you're installing them badly. So they had to, at the beginning, 8 or 10 years ago, they had to send teams over to train people so that everybody knew how to use these effectively and get the maximum benefit. Things are slightly better now, but that is an absolutely crucial part of the training. And we've got our first courses tied into the construction colleges, where they do the training on site. They train bricklayers and so on these sites normally. And we're just doing a trial of our first courses with them jointly this year. So that's just underway at the moment. We had our own courses, but just trying to tie them into colleges, these normal colleges that everybody uses. It's just a first trial we're working on right at the minute.
Thanks, John. Good to get those extra insights there. And maybe a question for Professor Wolfgang and Suzanne in Germany, because we heard about John in terms of how they're sort of reaching out to all the major architecture schools in the UK university cohort, it seems, and trying to see if we can include, some significant passive house modules in their core curriculum. Is that already the case in Germany, that anyone doing an architecture course would automatically get training in passive house as part of that, or not?
No, unfortunately not. So we are working very hard on this. But it's not so easy to implement new things in curricula at the universities. People who are in charge of university or lecturers at the university know about this. Therefore, we are working on several paths. So of course, would be the best if a university just takes it over and says, okay, we go with high energy efficiency, we go with passive house from now on. But if this is not possible to start this because the curriculum is already there, then you could start also with like John and also Barry showed, start with project work. So with this design competitions, or with just starting with energy balance with PHP, and then you can convince also people at university to really implement passive house right from the beginning of the first year of study for our students. This is the goal, and we are here to improve this and go further to this goal.
Thank you, Suzanne. Professor Wolfgang, did you want to talk about the situation in Germany as well?
Well, I have been a professor for building physics in Innsbruck University, and know a little bit about how difficult it is to have new content in the university framework. But it's doable, and it's growing. There are more and more universities, more and more colleagues who are going to include that type of content in their curricula. And yes, the important thing is, it's not really that new We know about the basics of building physics, partially since more than 100 years. It has been used in the past. We now can do even better than we have done in the decades before, because we learned a lot of things, and a lot of materials are now available which haven't been available in the past. For example, these low E coatings, which make it very easy to build energy efficient windows. So there is a lot of progress, and it can be implemented in the standard university curricula, not only in architecture, also in other parts, because energy efficiency is a general approach to all these issues and can be improved quite a lot if the universities focus on the topic.
Thank you, Professor. And I think just one more question for yourself, Professor Wolfgang. So we're, of course, I'm joining you from Sharm el-Sheikh in Egypt, where the COP27 negotiations are going ahead, and of course we're in Africa, and the energy efficiency requirements and the cooling requirements are very different from in Germany, where the passive house concept was developed. Are there approaches to adapt or modify the passive house approach to tropical climates? That would be an interesting thing to hear.
Yes, of course. It's not. There are already a lot of demonstration projects which took place in hot climates, because the general principle to reduce the amount of energy to keep the environment for people in a comfortable range. That's the same question from the physics that you want to keep it cool in a tropical climate, or also not too humid, or you want to keep it warm in a cold climate.
Yep.
These are the same types of, from the physics of heat, same types of issues. So the approaches can well be used in the hot climates. Of course, the specific way how, for example, you when build a window, those are different in tropical climates and in our climates here, but it's the same issues and it's the same things we can do. Maybe just one surprising thing, which is very clear when you think about this, that is the orientation of windows.
Yeah.
When we first learned it in cold climates, it's always good to have a south-orientated window if you
Yes.
are on the northern part of the globe. Yeah, and it's not so good to have eastern or western-orientated windows. So, and now if you look into the hot climates,
Yeah.
surprisingly the same. It's the west and east-orientated windows which make the most impact on solar loads. And it's the northern and southern oriented windows which don't have so much impact on the solar loads. Yeah? So it's quite interesting to look into these things. And the ways we do design of passive house, this is maybe something to understand here. A passive house is not something which is built in a factory in, say, Toronto, and then helicoptered into different places on the globe. A passive house is to be designed for the location it's built for, and this is where all the tools are made for. So PHPP or Design PH, Barry was talking about. These are tools with these tools, the architect, the designer, the engineers can develop their building in a way that it fits to the climate, and it fits to what the client wants, that it fits to what is available on the building market, on the construction market in that climate. This is the important thing. The physics is the basic, and the basic in these programs are these parts of well-known building physics, and now we use that to do a locally adapted design.
Thank you very much, Professor. Probably got time for one more question. Maybe go to Barry in the final minute. Barry, I noticed in some of your slides at the end there, you were starting to talk about embodied carbon and the embodied carbon in the materials. Is that sort of coming into the passive house standard approach? Typically when we think of passive house, we're thinking about energy reduction in operations.
Yeah, it is indeed, Robert. We're really starting to see that pop up all across the Passive House community globally. And indeed, the Institute are doing work on this that I know about, and Wolfgang and Suzanne can talk to that. And in the UK, we have had the emergence of Passive House Ribbon, which is a software that was designed by a guy in the UK called Tim Martell. And with that, we're seeing a lot of adoption of that software, and a lot of people looking at their projects, particularly around retrofit. This really comes into its own, because again, you know, buildings that are already built is where the real opportunity lies whenever we're dealing with global emissions and everything. So yeah, is the answer. It's really coming through, and we're starting to see a good understanding coming from the students in our college as well. These questions are the understanding is there, and then they're really starting to look at the solution from that point of view as well, around what can we do to the existing building stock rather than focusing on new build. So it's a bit of a step change there.
And I think that's important, particularly coming back to the Africa context and some of the other emerging economies where, unlike in the West, say, where, you know, I think we typically say 80% of the buildings that we'll be living in by 2050 are already built, so the challenge is more of a retrofit. In some of the African countries, it's the exact opposite. 80% of the buildings that will be around in 2040 aren't built yet. So there's a huge opportunity there for bringing that embodied carbon design in, as you said, Barry, and you can see Wolfgang nodding as well. And also Wolfgang thinking about those key issues in terms of orientation of the buildings, so we can start, you know, we can effectively leapfrog rather, some of those perhaps mistakes that were made in urban planning in the earlier days when not sufficient attention was paid to orientation and aspect of the sun and things like that. And perhaps we can get that right in some of these new developments that are coming up, applying the passive house techniques and approaches. So I think we need to draw a line under the session there. It just remains for me to thank you all very much indeed. Professor Dr. Wolfgang Feist, Suzanne Winkel, John Bootland, and Barry McGarren, and to Georgia Tsar for convening and organising the session, who's been quietly in the background as well, also deserves praise and thanks for her efforts. So we will close the session now. Thank you again, everyone, and we look forward to seeing you again. Bye.
Thank you very much.
Thank you,
Thank you,
everybody.
Robert. Thank you, Georgia. Thank you all.
Thank
Bye.
you.
Bye.